All right, this question is, what is a possible charge on a particle? Is there any choice that you can sort of immediately eliminate without really a calculation? Anybody just sort of expect those values to go, well, this clearly can't be possible. The reason why A can be discarded is because 10 to the negative 20 coulombs is less than 1.6 by 10 to the negative 19 coulombs. And that's a special charge. It's elementary charge, right? It's the charge of an electron if it's negative, or the charge of a proton if it's positive. So charges exist in the universe because they are collections of either electrons or protons. Okay. At this level of physics, let's understand it that way. Let's not worry about like the partial charges of quarks and things like that. All right. Because even those things sort of exist in groups of 2 or 3, and so the charges sort of add up. And so if all charges come from this, right? So groups of electrons that sort of add up from this value, the strategy to solve questions like this, and you're considering like which charges are possible, is to divide each of these by elementary charge and see if it's a whole number, right? When you divide them, then it's saying like, or you could put this in your calculator and add it to itself, and so okay, that's 2 of them. And then add it to itself again, and that's 3 of them, and you keep adding it until maybe you get to one of these numbers. But that's not maybe the most efficient way to go about doing it. Right? You just divide them. If you were to even consider the first example there, 6.4 by 10 to the negative 20th, and divide by 1.6 by 10 to the negative 19, your calculator will show you that you've got 0.4 electrons. And the 0.4 electrons is not possible. Okay. If you do the same thing with the answer suggested in choice B, 4 by 10 to the negative 19 divided by 1.6 by 10 to the negative 19, you'd realize that this would be the charge of 2.5 electrons. Right, so you're just sort of taking this and dividing it by elementary charge 1.6 by 10 to the negative 19. Right, and it equals 2.5 electrons. The 0.5 electrons is what we can't have. Right, can't have a fraction of an electron. Fundamental particle is indivisible as far as we know. As far as we know, right, there's like, in fact, our word atom comes from the Greek word atomos, indivisible. Okay, like the word for atom literally means indivisible because we thought atoms were indivisible particles. I'm going to skip choice C because it's the correct answer, because I want to disprove D. 9.11 by 10 to the negative 18 divided by 1.6 by 10 to the negative 19 is 56.93. And like this maybe like looks familiar because the mass of a electron is 9.11 by 10 to the negative 31. So like maybe that number looks familiar to us. It's like, oh, that's got to be right, but it's not. We can't have 0.9375 electrons. So again, it's not the 56 that's so bad, but this part, the fraction of the electron. How many electrons? How many protons? It doesn't tell us whether this is positive or negative. Well, let's say it's negative. How many electrons would it take to add up to this charge? If you solved it the inefficient way of just taking this number and adding it to itself and counting how many times you have to add it to itself, how many times would you have to do that until you got this number in your calculation? So 1.12 by 10 to the negative 18 coulombs divided by elementary charge, I'll write it like this, divided by 1.6 by 10 to the negative 19 coulombs, right? So that's elementary charge. Gives us, anybody have it? 7 electrons or 7 protons, right? So if it's negative. And so there, whole number, that's possible. Whole numbers are possible. We must have an integer multiple of elementary charge. Those are the possible charges in the universe. That could be like the noteworthy statement that you sort of ask, like, this is this particular problem, but any problem like this, if you have the idea in mind of possible charges are integer multiples of elementary charge. This is a value that's actually given on the data sheet, so you don't have to commit it to memory, but you probably work with it enough that you'll know. So it's an important value.